Hello everyone, I am Sonali Kanawade, Assistant Professor of Artificial Intelligence and Data Science of ASMS IOIT Pune. Today we are going to discuss about the kernel in Linux operating system. So first of all, kernel. Kernel is the core component of an operating system. This provides a platform for program and various services to run on top of it. The Linux kernel is modifiable according to the user's need. Overall, the Linux operating system and Linux kernel together provide a strong and user-friendly platform. So this is the schematical representation of kernel working. That is the in that the number of processes seen here. Then virtual machines, kernels, hardware resources, and pre-processed hardware virtualization are there. So kernel in operating system. What exactly kernel in operating system? How it is work? The kernel is a central component of an operating system that manage operations of computers and hardwares. It basically manage operations of memory and CPU time. It is core component of an operating system. Kernel act as a bridge between application and data processing, perform at hardware level using inter-process communication and system calls. Then kernel loads first into memory when an operating system is loaded and remains into memory until operating system is shut down again. It is responsible for various tasks such as disk management, task management, and memory management. Kernel has a process table that keep track of all active process. Process table contains a per process region table whose entry point to entries in region table. The kernel load an executable file into memory during executable system call. It decides which process should be allocated to processor to execute and which process should be kept in main memory to execute. It basically acts as an interface between user application and hardware. The major aim of kernel is to manage communication between software, that is user level application, and hardware, that is CPU and disk memory. Then objective of kernel is to establish communication between user level application and hardware, to decide a state of incoming processes, to control disk management, to control memory management, and to control task management. Then there are two types of kernels. First one is the monolithic kernel, and next is the microkernel. Then the core subsystem of the Linux kernel are as follows. First is the process scheduler, then memory management uh, unit, that is MMU, the virtual file system, VFS, the networking unit, inter-process communication unit, etc. The the Linux kernel subsystem contains process scheduler, the memory management unit, that's MMU, virtual file system, then the networking subsystem, and the inter-process communication unit. Uh, this is nothing but the Linux kernel. The process in that the process schedule contains the kernel subsystem is responsible for fairly distributing the CPU time among all the processes running on the system simultaneously. The next is the memory management unit, that is MMU. The kernel subunit is responsible for proper distribution of the memory resources among various processes running on the system. The MMU does more than just simply provide separate virtual address spaces for each of the process. The virtual file system, this subsystem is responsible for providing a unified interface to access stored data across different file systems and physical storage medium. GitHub or GitLab version control. First of all, why version control is important in Linux operating system or any operating system? Version control is not strictly necessary for reproducible research. It is admittedly some extra work to learn and to use in the short term, but the long-term benefits are enormous. People are more resistant to version control than uh, to any other tool because of the short-term efforts are the lack of recognition of the long-term benefits. Imagine that some aspect of your code has stopped working at some point. It was working in the past, but it is not working now. How is it? Please figure out where the problem was introduced. So, what is Git? Git has an open source distributed version control system developed by Linus Torvalds, developer of Linux. Then distributed distinct from centralized version. Authors can work asynchronously without being connected to a central server and synchronize their changes when possible. Complete audit trail of changes, including authorship, freedom for explore new ideas without disturbing the main line of work, collaborate with elegance on any file at any time. Advantages of version control is that it's easy to set up. Then every copy of Git repository is a full backup of a project and its history. A few easy to remember commands are all you need to most day-to-day version control task. So this is the Git and GitHub is the and GitLab is are both web-based platforms that provide version control services based on the Git distributed version control system. They offer similar functionality but have some differences in features, pricing, and target audience. So here are overview of version control with GitHub and GitLab. Git version control, repository hosting, collaborative tools, continuous integration and continuous deployment, CI/CD, community and social features, enterprise solution, pricing, customization, and extensibility. Thank you.